Hello बच्चों, welcome to Purnank. Please do like and share the video and do subscribe the channel. These questions will really be helpful for you in the upcoming examination. That one thing I can definitely assure you all. So let's solve this question. That's the question you would have got today as post. I believe you all would have tried, given your best here. See, method of substitution. That's the most important single method in indefinite integration. Okay, so when I don't get any form, I mean any form which is comparable to any standard form, any standard method, then I rely on method of substitution here. Okay, so let's start. See, what and the basis and the one of the very important hint for the method of substitution is if you have a combination of function like we have like composite function. Okay, if we have composite function, so we should remember that there is no chain rule type of thing in integration. So in differentiation you have composite function, you can easily directly differentiate it, but that's not the case in integration. So here it's a composite function because one function is a square, and within a square you don't have a normal variable like t square, x square, z square. No, you have another function within a square. Okay, so that's a composite function. So we don't have a choice normally in that case. What we should always try is whatever function you have within the like composite function, the inside function, you should try to replace that function by a variable. So that's a hint which I always keep in my mind and then use it accordingly. So here I will try by starting writing it as x into e raised power x by t bachcho. So now let's get to its derivative. So of course we need to differentiate it. So its derivative will be x e raised power x plus x dx, which is dt, and we know in numerator we have 1 plus x times dx. Okay, so that means we will have x plus 1 dx is nothing but dt over e raised to the power x, and mind here in the given integral you have x extra in the denominator which will get multiplied with x e raised power x to give us t again. Okay, so what do we get? So therefore our integral, so if I assume the integral to be I, which is though given, so it will be dt upon x into e raised power x, which is t, into 1 plus t whole square. So after applying the method of substitution, now we got it in a form which is integrable, I mean the standard form of partial fraction. So now let's start with partial fraction. 1 by t into 1 plus t whole square can be written as a by t plus b over 1 plus t plus c over 1 plus t whole square. I believe all of you will agree. Okay, or otherwise, see, otherwise what you can do is you can directly write the second factor or the second like term of the partial fraction as bt plus c upon 1 plus t whole square, but this is the form which I prefer. Okay, now after taking LCM and cancelling the denominator both the side, you will get a into 1 plus t whole square plus bt into 1 plus t plus c times t. Okay, now we have to definitely of course we have to get the values for a, b and c. So for that the best method which I think is the whatever linear factor you have in the denominator here, one by one equate them to 0, get the value of t, and one by one put those value of t in this expression. You should remember this is an identity statement. That means what? That simply means it is true for every value of t. So you can put any value of t of your choice to get the value of a, b and c, but we will definitely choose those values which will give us the value of t, the a, b, c as directly as we can. Okay, so that's what I said. So first put t is equal to 0. So that's the root for this factor t. Okay, so what do we get? So 1, this is a, this is gone, see, we got a directly. Now what? As I said, now second linear factor which is 1 plus t equated with 0. So put t is equal to minus 1, the second root of the linear factor of denominator. So what you will have, again you have don't have any t in LHS, so it remains 1. In RHS, now this is 0, this is 0, so we got minus c. So c is minus 1 c. We got two values of two unknown directly in single step. Okay, now let's move to the third one. Now see, as I said, it's an identity statement, so you can replace t by whatever value of t you wish, but of course we will choose the simplest possible value. So we have already used 0 and minus 1, so what is left according to me, I should use this t is equal to 1 because we haven't used it yet. So 1 is equal to t is 1, so it is 4a if I am not wrong. Yeah, so it's 4, a is 1, and then it's 2b. And then when I am putting it as t as minus 1, so it will be simply minus 1. Fine, bacho? And then 2, so 2b is equal to minus 2, so we got b as minus 1, bacho. And that's it, I think. Just check it out. Yeah, b is again minus 1. So that means, so this implies our dt over t into 1 plus t whole square. We know integral gets distributed over addition and subtraction. So it's a upon t, and a was 1, b is minus 1, and c is also minus 1. Okay, so it's integral over 1 upon t dt. b is minus 1, so minus 1 upon 1 plus t dt, and then minus 1 upon 1 plus t whole square. All are directly integrable. So let's integrate them. So this is nothing but, so I is equal to integral of ln mod t minus integral of ln mod of t plus 1 minus rather plus integral of 1 upon 1 plus t. Isn't that much? Of course we will replace it by, we'll add 1c there. And what was t? X into e raised power x. Yeah. So the answer should be, so therefore I is ln, and now using the property of log, so ln a upon b is ln a, ln a minus ln b is ln a upon b. So it's ln a x e raised power x upon 1 plus x e raised power x within mod, of course, and this is 1 upon 1 plus x e raised power x plus c. So that's the answer. So we use method of partial fraction. So that would have been, if so few of you would have missed it, forgot it, so that would have been a revision of the sort for the partial fraction and the method of substitution that holds the key in this question here, bacho.